So this talk is going to interdigitate nicely with what Hannah talked about and some of the others as well. I have no conflicts to declare. So again, how many ICU beds are needed? As we've heard, we don't want too many, we don't want too few. Now, Hannah has shown this seven-fold difference across developed nations in the per capita ICU bed base. And while it's possible that that represents a seven-fold difference amongst Western countries in the rates of critical illness, I don't believe that's likely. More likely, it represents the inability to really know, have an effective way to determine what's the right number of ICU beds for a given population. An important issue that several of the other speakers have mentioned is the substantial temporal fluctuations in demand for ICU beds, and I'm going to talk about that. So, how could we optimize the number of beds? Well, if we were economists, we could try to come up with a metric that we could then optimize with calculus and then figure out the right number of beds. But what would that metric be? There is no consensus, and the odds are that there is no way to get a consensus about a single metric that is the right metric. If you make widgets, then the metric is how much money you bring in. But for other things, for healthcare, it's not so simple. But in the real world, administrators and the people responsible have to do something. They have to decide how many beds to make, to staff, to build, whatever it is. And the evidence, and I don't have the details here, but I could give you them, is that there's published evidence that by and large, jurisdictions use the kind of yearly average bed information that Hannah alluded to earlier. But these long-term averages, as I'll show you in some detail with real data from Manitoba, don't account for the short-term fluctuations that occur over hours and days. So our goal in this study, which has been published recently and just earlier this year in Health Services Research, was to compare three different ways of looking at the census data of how many patients are in the beds to estimate how many beds you need as a starting point for doing that. So we looked at all Manitobans, adult Manitobans, over 7 years admitted to ICUs in 3 geographic areas. In Winnipeg, which is the capital, which contains most of the people in Manitoba, where there's 11 ICUs, 6 hospitals, 82 beds. And then South Rural, which is also reasonably well populated, and then the gigantic, remote North Rural area, which has few people, few ICU beds, but a huge amount of land. Now, what powers this is the ability to identify when patients enter each ICU and when they leave. And this is actually available from administrative data from the hospital abstracts Canada-wide. So we use those abstracts from Manitoba, and by putting them all in a row, you can figure out how many patients you had in the beds in any ICU you want at any time of day or night, any day of the year. So what we did, and this is the key calculation here, is we calculated, again, as Hannah alluded to nicely, as a sort of a foreshadowing of this talk, what we call the daily peak bed occupancy, which is the maximum number of patients in a given ICU that day, at any time during that day. The distribution of this represents the fluctuations, the day-to-day fluctuations in census in a given ICU when you look at it over a year, say. Now, there's a concept here that, again, has been alluded to before, and I call it conglomeration, but it could equally be called regionalization to some degree. When you talk about multiple ICUs, whether within the same hospital or between hospitals, as being conglomerated, what I mean is they function seamlessly as if they were a single ICU bed base. So if there's an empty bed in any of the conglomerated ICUs, the next patient could go there, and they're not left waiting. They might have to be transported between hospitals or from one part of the hospital to another, but there's not a firm block that keeps them out because there's an empty bed across town or down the hall, whatever it is. So that's conglomeration. Now, we always, in this analysis, assume conglomeration within a given hospital, but as Hannah so nicely pointed out, that isn't such a great assumption in many hospitals where there are silos where never the twain shall meet. For some analyses, as I'll show you, we can consider conglomeration of ICUs across the hospitals in one of those 3 geographic regions. And we always rounded bed estimates up to the next integer because you can't have 2.5 patients in a bed. That would be 3. So the first method is the average yearly method. So it takes the total number of bed days that were used in that year in that region, divides by 365, and then uses this fudge factor of 0.8 under the presumption that we don't want to have more than 80% average occupancy because of some evidence I reference here that higher occupancy rates than 80% are associated with poorer outcomes. So that's the first estimate, method 1. The next method is the regional level daily peak bed occupancy method. This considered all beds in the region to be conglomerated and calculated accordingly the regional daily peak bed occupancy. So across all the ICUs in that region, we calculated for each day the maximum number of patients simultaneously at any time occupying the beds in those ICUs in all the hospitals in that region, and then generated the distribution of that for the year. And so, for instance, the 95th percentile of that distribution for that region tells you that the number of simultaneously occupied ICU beds over the region that was exceeded 5% of the days, which is 18 days a year. The third method is similar, but is the hospital level daily peak bed occupancy. So each hospital was independently expected to meet its own ICU demand. So we calculated the distribution of daily peak bed occupancy for each hospital separately, and that's the fluctuation in the hospital ICU census. We accumulated that, not conglomerated, but accumulated that for the region. Let me come back to that. The 99th percentile for a given hospital is the number of simultaneously occupied ICU beds exceeded in that hospital on 1% of days of the year, which is 4 days a year. And the regional, we added those together, the regional 99th percentile of the daily peak bed occupancy was the sum of the individual hospital 99 percentiles for each hospital in the region. So it's a little hard to understand vaguely, but let me give you a simple example. 2 hospitals, each with 1 ICU. Here's the daily peak bed occupancy in each unit for a week. Now, if those two hospitals or 2 ICUs were conglomerated, so you can see that at no time on any day was there more than 6 people in the 2 hospitals, in the 2 ICUs together. So those 2 hospitals, if they were dealing seamlessly as a single bed base, would need 6 ICU beds because there were never more than 6. But if each hospital had to do its own thing separately, independently, the maximum in each hospital at any day of that week was 4. So that region with the 2 hospitals, made up of the 2 hospitals, would need 8 beds. And that's the difference between methods 2 and methods 3. So here's method 1 results. This is the average daily bed occupancy over the whole year. And I show you on the left in orange the actual number of beds in each region. And you see that based on the average yearly occupancy, the average number of bed days per day with that 0.8 fudge factor, that each region would need way fewer beds than it actually has. Now this is the distribution of daily peak bed occupancies with no bed sharing, method 2, and with bed sharing, method 3. And this is just the distributions. You don't need to look at all of these numbers, but I do want you to notice the far right-hand column. The far right-hand column is the maximum minus the median divided by the median, which is some measure of the magnitude of the daily fluctuations compared to the median. And you see that even in Winnipeg, which is the biggest area, the biggest bed base of ICU beds in Manitoba, even there, the fluctuations are on the 20 to 40% range. And in the small rural regions, the North Rural region, which has got few people but very few ICU beds, you see that the fluctuation in ICU bed census is enormous, 300%. Or 200%, depending on whether the beds are shared or not shared across the hospitals in that region. So let's talk about the daily fluctuations. This is method 3 with no bed sharing between hospitals. And so I've shown you, depending on whether you allow or can accept exceeding occupancy 5% of the days, 1% of the days, or no percent of the days, the number of beds you would need compared on the left to the number of beds that there actually had in those areas. So what you can see is that without sharing between hospitals, where each hospital in a region was forced to manage its own demand separately, independently, you always needed more beds than indicated by the average yearly usage, which is method 1. Especially in regions with a small bed base. So in the North Rural area, which has 8 beds, but the average daily census would suggest, over the whole year, would suggest you only need 2. In fact, if you only had 2, you'd have very frequently your fluctuation in demand would outstrip the number of beds you actually had. Also, as seems obvious when you think about it conceptually, the fewer days per year it's considered acceptable to exceed the maximum number of beds that you have, the more beds you need to avoid that. Okay. So this is method 2, which is with the assumption that the bed base in a region is shared amongst all the ICUs in that region. And I show you the numbers there. And method 1 still underestimates the number of beds needed, except in the largest region. So I'm going to put them together, because I want to show you one other thing, and that is when you compare yellow with green, whether it's 18 days a year, 4 days a year, or never that it's acceptable to exceed, for demand to exceed supply, yes, demand to exceed supply, in any of those pairs of yellow-green, you need fewer total beds if there's bed sharing, regionalization, whatever you want to call it. I've used the term conglomeration. And that makes sense, as we've talked about. Okay, so first, I think what this data shows is that bed supply decisions based on what most people appear to use, what most jurisdictions, at least that have published their decision-making algorithms, have shown that they use this long-term average usage. Bed supply decisions based on those kinds of calculations will result in a supply inadequate to deal with the actual fluctuations in demand, call it surge capacity, even including the leeway, that 0.8 fudge factor. Using the distribution of daily fluctuations, the daily peak bed occupancy calculation, to assess the actual magnitude of your own day-to-day fluctuations is better. And by the way, if you have data that tells you when patients came into the ICU, date and time, and when they left, I can give you some SAS code that can generate the daily peak bed occupancies. It's easy. A key policy issue that won't be decided by us, but has got to be decided by the policymakers somehow or another as a representation of society, is how many days per year you can tolerate having too much demand for your supply. That's method 2 versus method 3. So for instance, when you go from 18 days to 4 days a year, from 5% of the days to 4%, from 5% to 1% of the days per year, that you think it's acceptable for supply to outstrip demand, for demand to outstrip supply, sorry. In our 3 areas of Manitoba, you need 4 to 40% more beds. Avoiding it entirely, if you want to resource your region so that you never have too few beds for the amount of fluctuation in demand that you actually see, the consequence of that is clear. You're frequently going to have very low occupancy rates. So in Winnipeg, the largest of our 3 regions by far, if we wanted to resource the number of beds so that we never had, according to the census data, too few beds to satisfy the demand that we had during this time period of the study, we would have less than 70% occupancy on 25% of days. Maybe that's okay, but maybe not. And that's a societal decision that has to do with some of the issues that were brought up in the earlier talks, primarily economic issues. So, effective bed sharing, what I call conglomeration or regionalization, reduces the number of beds needed. The reason is statistical but easy to understand. The fluctuations for an entire larger conglomeration is less than the sum of the fluctuations from the components making up that conglomeration. And so, for instance, we'd need 12 to 36% fewer beds needed in our 3 regions with conglomeration. And the benefits, as I showed you in that complex distribution slide, the benefits are bigger of conglomeration when your bed base is small than when your bed base is big. Now, the unavoidable consequence of having a hospital or region with a small ICU bed base is that if you need to, because it's remote, as was alluded to in an earlier question, if it's remote and you therefore must be able to manage its own surges in demand because it's so far away from every place else, is that average bed occupancy is going to be low. You just have to accept that. In our 2 rural regions, which are both fairly small, even with regional bed sharing and allowing demand to exceed supply 5% of the days per year, the average occupancy in both of those regions of the ICU beds will be under 50%. So what we've shown is that bed census is a superior starting point for evaluating ICU beds, because I don't want to pretend and don't believe certainly that census numbers tell you everything you need to know about how many beds you need. In particular, filled bed counts can underestimate the numbers of beds needed. Patients triaged away when the units aren't full, as we saw in some of the literature that was presented in earlier talks, strongly suggested that this happens. Patients triaged away never get to the ICU, but might have gotten there if there were more beds available. They aren't counted in census numbers. At least not the census numbers that I had available. Evidence indicates that outcomes are worse when ICUs are full, so that's one thing. On the other hand, filled bed counts may overestimate the number of beds needed. I work in a place now where the bottleneck is not ICU beds, but ward beds. We have patients who frequently stay in the ICU a day, 2 days longer, because there ain't any ward beds to send them to. So inefficient or unavailability of ward or step-down beds increases ICU census, but those patients don't need the ICU, but they're just there because there's no place else to send them. So for both of these reasons, census numbers don't tell the whole story. So I had a number of collaborators that helped me with this, and I'll take any questions if we have time to do so.